The symbol for linear acceleration is comma A. What is linear acceleration? Linear acceleration is the rate of change of linear velocity with respect to time. I repeat that. Linear acceleration is the rate of change of linear velocity with respect to time. Or I can say is A equal to V2 minus V1 over the time. Now, V2, V1, and T. Now, your V2 is the final linear velocity. V1 is the initial linear velocity. While our T is the time taken. Our T is the time taken. And please, I want us to note that the units for linear acceleration is meters per second squared. Is meters per second squared. Now, I can break this equation further. I can make V2 the subject. How do I do that? I will transpose. So V2 minus V1 will come over. Equal to A times T what next? I want to make my V2 the subject of formula. So I will add V1 to both sides. So my minus V1 will move on to my right hand to become what? A plus V1. So therefore, my new equation becomes V2 equal to AT plus V1. I can also write it as V2 equal to V1 plus AT. Here is our equation. So V2 is your final linear speed, V1 is your initial linear speed, your A is your linear acceleration, and T is your time. So this is the formula for linear acceleration. Let's look at angular acceleration. Now, angular acceleration is the rate of change of angular velocity with respect to time. It is the rate of change of angular velocity with respect to time. The symbol we use for this is alpha. Alpha. In chemistry, they call it alpha. They call it alpha. All right. So it means that angular acceleration is equal to omega 2 minus omega 1 over t. Now, omega 2, omega 1, and t. Our omega 2 is the final angular velocity. Okay. Omega 1 is the initial angular velocity, while our t, as you all know, is the time taken. So here is the formula for angular acceleration. But I can still break this formula down. I can make my omega 2 the subject, so I will cross multiply again. So omega 2 minus omega 1 is equal to angular acceleration times t. Now I want to make omega 2 my subject, so I move my omega 1 to my right. It becomes plus omega 1. So we now have omega 2 equal to alpha t plus omega 1. Or I can write it as omega 2 equal to omega 1 plus alpha t. Here is my next equation. This is our equation again for angular acceleration. And please note that the unit for angular acceleration is, the unit for angular acceleration is rads per second squared. It's rads per seconds squared. This is the unit for angular acceleration. So now let's look at a connection between linear and angular acceleration. Now if you remember, I was saying that linear acceleration is A equal to V2 minus V1 over T. And also, if you remember, we said that V is equal to what? RW. Good. Now, for a motion in a circle having a constant radius, my V1 will be R omega 1, while my V2 will be R omega 2. Now, if you are wondering why my R did not change, is because the motion in a circle is having a constant radius. So because the radius is constant, my R remains the same for V1 and for V2. But my angular speed was changing. Now I can replace my V2 with this and my V1 with this. So therefore I can say my linear acceleration is equal to V2 is RW2, and I have RW2 minus my V1 is RW1 is RW1 over T. Now, guys, I can factorize my numerator because I have a common factor on both sides, which is R. So I can bring out my R, open the brackets, becomes omega 2 minus omega 1. Over T. Now, let's move on. If you remember, I was saying that my angular acceleration, if you remember please, is equal to what? Omega 2 minus omega 1 over T. Over T. Now, if you look at this equation right here, you will see that omega 2 minus omega 1 over T is my what? Angular acceleration. So therefore, I can say that my linear acceleration A is equal to R. I will take off this and put my what? Angular what? Acceleration. Here is a formula that connects linear acceleration to angular acceleration. Okay, so the speed of a shaft increases uniformly from 200 to 700. So this first one is my angular speed, is my initial angular speed, omega 1, which is 200 rev per minute. Remember, we must convert to what? To rads per second. Very important. That comes 200 times what? Times 2 pi over 60. Okay? When you punch that in your calculator, you get 73.3 rads per second. All right, so the next one is to 700 rev per minute. So that is my final angular velocity is 700 rev per minute. So we convert this to rads per second, becomes 700 times 2 pi over 60. That gives us, when you punch this in your calculator, you should get 20.9 rads per second. Okay? All right. We are giving time. The time is 12 seconds. So my T is 12 seconds. Okay? Question, we are asked to find the angular acceleration. Therefore, I can say my angular acceleration is equal to omega 2 minus omega 1 over T. What is that? Now omega 2 is 20. Now omega 2 is 20. So my omega 2 is 73.3 minus omega 1 is 20.9 over T. My T is 12. So guys, when you punch this in your calculator, our answer should be, to one decimal place is 4.4 rads per second squared. That is our angular acceleration. The next is to find the linear acceleration, and it's giving us A equal to R times angular acceleration. Now, my radius is half of my diameter, which is R equal to 40 over 2. That gives us 20 millimeters. Okay, we can convert these to meters. We have 20 over 1,000. That gives us 0.02 meters. So now I can find my linear acceleration. Becomes my R is 0.02 times my angular acceleration is 4.4. All right. So when you punch this in your calculator, our linear acceleration will give us 0.088. 0.088 meters per seconds squared. That is our final answer. Yes, so what you are seeing here are other formulas that we can use to solve for linear motion and angular motion. So guys, I want us to note these formulas. They are very, very important when solving questions relating to linear motion and angular motion. I gave us this already. I gave us this formula. We've seen this and we've seen this. All these are other formulas that you have to note. And I want us to note that the S is the displacement, while the theta is the angular displacement. Theta is the angular displacement. Okay? And your S is your linear displacement. With this, we can solve any question that is given to us as relates to linear motion and angular motion. Please, I want you to listen attentively. It says the shaft of an electric motor was at rest, initially at rest, accelerates uniformly at 0.5 seconds. That's my time. So my time is given as 0.5 seconds. Sorry, 0.15 seconds, yes. At 10 rads per second squared. That is my final angular speed, is 10 rads per second squared. No? What is this? This is my what? My angular what? Acceleration. That is my angular acceleration. Is giving us 10 rads per second squared. Per second squared. Now, it says find the angle or determine the angle in radians turned through by the shaft in this time. So my angle theta is unknown. And please remember that it says that the shaft was initially at rest. That means my omega 1, my speed at my initial speed is what? Is 0. Because the shaft was initially at rest, so my initial angular speed will be 0. Now, which of the formulas right here can we use to solve this question? To solve this question, I can use this formula here, because I'm given the time, I'm given the initial angular speed, I'm given the angular acceleration, I'm giving my time. So I can say theta is equal to omega 1 times t plus angular acceleration t squared. So I log in the values. Remember, my omega 1 is 0, so it's 0 times t. T is 0.15 plus my angular acceleration is what? Is 10 times t. T is 0.15 squared. 0.15 squared. Okay. Therefore, my answer is what? 0 times 0.15 is 0 plus 10 times 0.15 squared gives us what? Gives us 0.0225. 0.0225. Therefore, my final answer or my angle turn is 0 plus 10 or 10 times 10 times 0.025 will give us what? 0.225 rad. So here is my final answer. So that is the angle turned by the shaft in that time. Question: a grinding wheel makes 300 revolutions. This is my